If you could go back to your early life and change or augment one aspect of your mathematical education, what would it be?
So what happened at Chicago after 3 years, didn't take any mathematics. I really wanted to study science, so I decided to go to Berkeley, where I kind of had grown up more or less. And I enrolled as a double E major, and I took number theory classes there. So actually from D.H. Lamer, who turned out to be my advisor. But after that fourth year, I still hadn't accrued enough credits to actually have a degree. And in those days, if you, after 4 years undergraduate, no degree, you can be drafted. So I thought, well, okay, maybe instead of being drafted, I could do something else. I could enlist. And I looked at the brochures. Army, 2 years, doesn't look good. Navy, 3 years. Air Force, 4 years. Oh, travel the world, get the duty assignment you want, everything. So I enlisted. And turns out that there was a well-known that I was, if you're sent to a technical training school and you do best in your school, in your class, you can get any assignment you want. So I studied like crazy and could type like mad and so forth, and was best in my class and got sent to Alaska with 4 other people, because it turns out in the real world, where you get sent depends on knowing the guy in the headquarters division that makes the assignments. That's how you really decide. So I was up in Alaska for 3 years, and I volunteered to work at night, and the days were my own, so I was a full-time student at University of Alaska. Got a physics undergraduate degree. They weren't accredited in mathematics, and so that was, but that was a detour that maybe in another life I might not have taken. I might have gone straight to university.
Did Lamer express any opinions about going to Alaska and enlisting?
No, because he didn't know. I was just an undergraduate. I disappeared. And while I was there, I met Donald Coxeter from Toronto, who was visiting, and he offered me a TA-ship at Toronto, which I didn't take. But then I came back to Berkeley as a grad student and worked with Lamer. Lamer was kind of a catch-all advisor. If you're doing algebraic topology, you do Spanier, or algebra, you do Rosenlicht or something. Logic, you do Tarski. But I was just doing kind of combinatorial number theory type things, and that was what Lamer liked. So I worked with him, but I never took a course from him as a graduate student, and could have learned more.
How long did you take before you switched from EE to math?
Well, I was never in E. I just had to pick something, you see. So I took mechanical drawing. I learned how to draw lines with arrows. Really good. I can draw very good arrows, yeah. But I took Russian, I took, all that kind of stuff. But, when I was graduating, it kind of never occurred to me that I'd have to get a job, because I'd always been in school all the time. I thought school was great, so I only applied to 2 places, Bell Labs and IBM. And that kind of disappointed Lamer. He thought, students should be professors, right? Well, what was I going to do? And I know I had a friend who was at Berkeley at the time, Harley Flanders, who said, you go to industry, you'll be dead in 3 years. Well, okay, I think he was wrong. In fact, he's dead, right? But anyway.
And what were your interactions with Lamer like? I mean, he's certainly an interesting...
Well, Lamer was an interesting guy. He has a very wry sense of humor. And I just learned relatively recently that during the McCarthy era, people at the University of California, faculty, had to sign loyalty oaths, or at least they were supposed to. And Lamer decided he didn't want to. So he was released. And then that kind of blew over. He came back and became the chair of the department, actually. And in fact, it turns out his father, D.N. Lamer, was also at Berkeley and was the chair of the department in the 30s. In fact, D.N. Lamer published the first kind of correct list of prime numbers up to 10 million. And people pointed out it wasn't quite error-free. He made one mistake. He included 1 as a prime, which nowadays people usually don't think it's a prime. But Lamer was very computationally oriented, one of the early people. For example, in one of the qualifying exams, when he asked a student, suppose you have 100 equations and 100 unknowns, linear, how would you solve it? And the student said, well, set up determinants. And Lamer said, have you ever tried to evaluate a 100 by 100 determinant? And the student said, I'm not interested in that question.
And what was your thesis on?
The thesis had to do with something that was more or less written when I was an undergraduate. So when I was an undergraduate, he had a letter from Sherman Stein at Davis. And there's a problem about decomposing fractions into sums of unit fractions, so-called Egyptian fractions. And you'd like to know, well, Fibonacci in 1202 proved you could always decompose a positive irrational to a sum of distinct unit fractions. And the question is, suppose your initial fraction had an odd denominator. Can you then do the same thing with all the unit fractions with odd denominators? Well, yes, it turns out you can. Or suppose you want all the denominators to be perfect squares. Can you do it? Well, you can do it if you have a chance. Chance means if you take the sums of the reciprocals of all the squares, you get pi squared over 6. This is Euler's great discovery. So you can't have any rational bigger than pi squared over 6. On the other hand, it can't be negative. Well, could you get everything in between? Well, almost. If you use 1 over 1, it's got to be at least as big as 1. If you don't use 1 over 1, which is 1 squared, it can be at most 0.6 something, which is pi squared over 6 minus 1. So there's a missing gap. Other than that, any rational, you can actually do it. And in fact, I wrote this to Paul Erdős at the advice of Lamer, and he wrote back in 59. And this kind of began our first interaction with Paul Erdős, of which I have a long history.